Welcome to Section 2, AWS Shared Responsibility Model and Exam Tips. In this section, we will get an overview of the AWS Shared Responsibility Model, that is, the responsibilities we as users have, as well as the responsibilities that AWS have. We will get a quick overview of the exam, as well as a mega quiz by reviewing the key concepts and validating the knowledge gained in the previous courses and sections. Welcome to video AWS Shared Responsibility Model. In this video, we will look at the different types of AWS Shared Responsibility models that are available and what that means for us, as well as the responsibilities that AWS have. The AWS Shared Responsibility Model defines what AWS is responsible for and what you as a customer are responsible for. There are two white papers that I recommend reading for this particular section. The first one is the AWS Security Best Practices, and the second one is Overview of Security Processes. Under the Shared Responsibility Model, AWS and customers work together towards security objectives. AWS defines shared responsibility models for each of the different types of services they provide: infrastructure services, container services, and abstracted services. We will take a look at each one of them a bit later on. But first, we will start with the AWS responsibilities. We will be looking at the most important responsibilities that AWS have. First of all, there is the fact that they need to decommission storage devices as per industry standards. When AWS will decommission storage, for example, EC2 instances or EBS volumes, it will not delete the underlying physical media, but will mark the storage blocks as unallocated. AWS uses secure mechanisms to reassign the blocks elsewhere. Then we have physical server level. For example, with EC2, different instances running on the same physical machine are isolated from each other via the Xen hypervisor. Customer instances have no access to raw disk devices, but instead are presented with virtualized disks. AWS are also responsible for facility or data center security and protection. They're responsible for fire detection and suppression, climate and temperature monitoring, power monitoring, as well as management. For example, electrical, mechanical, and life support systems need to be monitored. Then they need to ensure physical access is secure. So this is monitored by security staff utilizing video surveillance, intrusion detection systems, and other electronic means. Authorized staff must pass two-factor authentication a minimum of 2 times to access data center floors. All visitors and contractors are escorted by authorized staff. They are also responsible for network security, for example, secure network architecture. Their network devices, including firewalls, are in place to monitor and control communications. Transmission protection. They use SSL for API access endpoints. Then there is the Amazon corporate segregation. So the AWS production network is segregated from the Amazon corporate network and will require different sets of credentials. And we have seen that AWS provide a fault-tolerant design with the availability zones and regions that they provide, as well as edge locations. Some other responsibilities that they have are around network security. They have to provide DDoS protection, man-in-the-middle attacks protection. EC2 instances can't send spoof traffic, and port scanning is not allowed even if you own the environment. To allow this, you would have to make a request to AWS before attempting to do penetration testing. Packet sniffing by other tenants is not possible. For example, they cannot listen to one another's traffic, even if they are on the same host, but AWS still recommend you to encrypt sensitive traffic. Now let's look at some of the responsibilities that a user has within the AWS Shared Responsibility model. First of all, there are the Amazon Machine Images, or the AMIs. We have seen that a user is responsible for creating new and custom Amazon Machine Images. The user is responsible for their operating system on their EC2 instance. They are responsible for patching it up, for installing new software. We've seen that users are responsible for their applications, for data in transit, for data at rest, for data stores. So we've seen that they are responsible for different types of encryption, for example, how to encrypt their data. They can specify different methods that AWS offers, but this needs to be a step that is explicitly defined by the user rather than something that comes out of the box from AWS. It is the user's responsibility to ensure encryption and where they want to store their data, and the lifecycle management of data, for example, in S3, versioning their objects, and so on and so forth. Then we've seen credentials are very important, and they are the user's responsibility, allowing users to have credentials to the console or programmatic access or both, rotating their keys and password management policies. We've seen that they are also responsible for policies and configuration for different IAM roles, as we have seen beforehand. Multi-factor authentication should be enabled as a security step when defining your users or interacting with your environment. That should be enabled to ensure security for your environment. We have seen that we can enable multi-factor authentication with S3 buckets, so users won't be allowed to delete objects from a bucket unless they provide a code. Then there is Trusted Advisor, so this is going to help us to see any vulnerabilities within our environment. For example, are there any ports open to the world, or so on and so forth. You wouldn't want that in a production environment. Then users are responsible for managing their VPC. We've seen that if they want a custom VPC, they have to manage it themselves. Network access control lists are another feature that users have to manage themselves. We've seen that even though AWS offers the default network access control list for a default VPC, to customize it, you would have to add your own security rules to it. Then we have security groups. We've seen that is a good mechanism for protecting our EC2 instances. We can restrict the traffic on specific ports. We can restrict traffic only to certain IP addresses. Also, we can allow security logs to be captured using CloudTrail, and we can have a general overview of what has happened within our account. But this is a responsibility that the user has. AWS provides you with the means, but you are responsible for enabling these means. Let's look at the AWS shared responsibility models for the different types of services that AWS supports. First of all, there are the infrastructure services, and they include compute services such as Amazon EC2, as well as EBS, autoscaling, and Amazon Virtual Private Cloud. We've seen that with these services, we can architect and build a cloud infrastructure using technologies similar to and compatible with on-premises solutions. And we are responsible for controlling the operating system and configuring and operating any identity management system that provides access to the user layer of the virtualization stack. Then there are container services, and they typically run on separate Amazon EC2 or other infrastructure instances, but sometimes we don't manage the operating system or the platform layer. AWS provides a managed service for these application containers, and we are responsible here for setting up and managing network controls such as firewall rules, and for managing platform level identity and access management separately from IAM. And examples of container services include Amazon Relational Database Service, or RDS, EMR, and AWS Elastic Beanstalk. And then we have abstracted services, which include high-level storage, database, and messaging services such as S3, Glacier, DynamoDB, and SQS, SES. And these services abstract the platform or management layer on which we can build and operate cloud applications. We access the endpoints of these abstracted services using AWS APIs, and AWS manages the underlying service components or the operating system on which they reside. We share the underlying infrastructure and abstracted services, and they provide a multi-tenant platform which isolates our data in a secure fashion and provides for powerful integration with IAM. So let's go and have a quick look at what they actually look like, what these models look like. So we have the shared responsibility model for infrastructure services, and we can see that these are the services managed by Amazon Web Services, and this is what the customer manages. So when we talk about infrastructure services such as EC2, we would be looking at AWS is responsible for the global infrastructure, for example, the regions, availability zones, and edge locations, as we have discussed beforehand, the endpoints, as well as foundation services, compute, storage, databases, and networking. Whereas we, as customers, we would be responsible for client-side data encryption and data integrity authentication, server-side encryption, for example, file system and/or data, network traffic protection, encryption, integrity, identity. We'd be using operating systems, networks, and firewall configurations. We would set our own patches and so on and so forth. Platform and application management, and also we're responsible for the data, for managing the data. When we talk about containers and the responsibility model that we share with AWS for container services, we can see that the operating system and network configuration is going to be managed by AWS. The rest of them are the same: foundation services, global infrastructure, and AWS endpoints, but you also get platform and application management. But you still have to enable firewall configuration. You're still a bit responsible for that. For example, with RDS, we can enable different security groups, and we can talk to different instances on particular security groups, on particular ports, and we can have that control over our managed service. And also with operating systems and network configuration within a container service, AWS is responsible for managing the operating system, but we can say, I want the instance to be patched with a new version, and you can decide when that is going to happen. But you won't go in and explore that and just type, I want this update to happen. You would make an API request to AWS to allow that update to occur. And then we have abstracted services, and we can see that AWS is responsible for the endpoints, the foundation services, the global infrastructure, the operating system, network, and firewall configuration, as well as network traffic protection provided by the platform, that is protection of data in transit, server-side encryption provided by the platform, protection of data at rest. And we have seen that you can enable these if you want to, for example, with client-side data encryption, data integrity authentication, as well as you are responsible for managing your customer data. We've seen that AWS offers these particular options for you, but for example, with S3, you still have to go and specify that you want encryption to happen. And that is where we can see the overlap between the AWS service for encryption, as well as the customer's responsibility for encryption of data in S3 or different application services. There is an overlap, but we need to remember that we are still responsible for enabling that step. And those are the main differences between the shared responsibility models for the different service types that are supported by AWS.